Let's discuss limits. Limit of a function. The limit of f of x as x approaches c is the number that f of x approaches as x approaches c, as long as x doesn't equal c. So what does that mean? Let's look at this right here. Here's what that means. The limit of f of x as x approaches c. It means this. As x gets closer to c, what does y get closer to? So when you see a limit and it doesn't tell you what it's equal to, that's what it's asking. It's asking, what is y getting closer to as x is getting closer to c? Here's a quick example looking at a graph. This question right here is asking, what is y getting closer to as x gets closer to 3? If we were traveling up this curve, we're getting closer and closer to 3 as far as the x value goes. What is y getting closer and closer to? We can approach it from both sides. As we're getting closer to x equals 3, what is y getting closer and closer to? Well, it's getting closer to 8. So as x approaches 3, y approaches 8. Let's discuss some symbols here. This here at the top says x approaches 3. That's what that means. X approaches 3. Here on the left, what this is saying is x approaches 3 from the left. This little negative here is after the 3, and it's superscript. It means approaching from the left. Over here on the right, it's saying x approaches 3 from the right. This little plus superscript means you're approaching it from the right. So how would you approach 3 from the left? Well, you would pick a number that's close to 3 from the left on a number line. So here's a number line. Something close to 3 is 2.9. That's pretty close. But then you want to get a little bit closer. Well, what's closer than 2.9? How about 2.99? That's closer to 3. Well, what's closer than that? 2.999. As we pick numbers closer and closer to 3 from the left, that's what's illustrated here with these green numbers. From the right, what's a number that's close to 3 from the right? How about 3.1? That's pretty close. Can we get closer? Sure. How about 3.01? What about closer? 3.001. From the right, we're getting closer and closer to 3. We're not actually going to get there. We're just going to get closer and closer. So x approaches 3. X approaches 3 from the left. X approaches 3 from the right. A couple facts about limits. Fact 1, a limit may exist or it may not exist. Fact 2, if a limit does exist, that limit must approach a single number. For a limit to exist, it must approach a single number. This here is very important. Must approach a single number. Here's an example problem. Use tables to find the limit of 2x plus 4 as x approaches 3. So to figure this out, we were going to have to approach 3 from the left, which is what we see here. X is approaching 3 from the left, and we're going to have to approach 3 from the right. As you approach 3 from the left, and we can see here, we got 2.9, 2.99, 2.999, 2.9999. We're getting closer and closer to 3. And over here, in this table on the right, we got 3.1, 3.01, 3.001, 3.001. The numbers here are getting closer and closer to 3 from the right. So going back to this first table, what are the what are the y values getting closer to as we're going down this table? Well, we can see here at the beginning 9.8, and then it goes 9.98, 9.998, the next one 9.998. You can see here that it appears as these numbers are getting closer and closer to 10. Let's look at this other table. We get 10.2, 10.02, 10.002, 10.0002. looks like these numbers are also approaching 10. So from this table we can see that this limit is approaching 10, which we could write then the limit as x approaches 3 of the function 2x plus 4 equals 10, which is saying as x gets closer to 3, y is getting closer to 10. Here's another example, similar problem. Use tables to find the limit. And we can see here it says that x is getting closer to 0. So if you look at our table, from the left of 0 on a number line, we got negative 0.1, and then negative 0.01, negative 0.001, and then negative 0.0001. Those x values are getting closer and closer to 0 from the left. As you look at the table on the right, the x values 0.1, 0.01, 0.001, 0.0001, those x values are getting closer and closer to 0 from the right. So the question is, what is y getting closer to? Notice these directions are a little bit different. It says do it correct to 3 decimal places. So as we look, as we go down this list, it's hard to tell what these numbers are getting closer to. We got 2.868, 2.732, 2.7196, 2.7184. Look at the numbers over here on this other table. It's hard to tell what they're getting closer to. But as we compare from each table, for example, if we compare these first y values, don't see a lot similar there. If we compare the second y values, getting closer. They both have a 2.7 in common. If we compare the third ones, they both have in common 2.71. Finally, if you compare the last ones that we have listed here to 3 decimal places, you get 2.718, 2.718. Notice also the 4th decimal place, a 4 and a 1. If these numbers were rounded, they would still round to 2.718. So we could say the limit as x approaches 0 of 1 plus x to the 1 divided by x is approximately, and I need to use approximate symbol here because we are rounding, it's approximately 2.718. That's correct, 3 decimal places. 3. Use tables to find the limit of x squared plus 4 as x approaches negative 2. As you look down here on the left table, our x values are getting closer and closer to negative 2 from the left. As you look at the table on the right, our x values are getting closer and closer to negative 2 from the right. Just to make sure that's clear, if I draw a number line and put negative 2 on it, negative 2.1 is on the left, negative 1.9 is on the right. So in this first table, what are the y values getting closer and closer to? As we go down this table, it looks like it's getting closer and closer to 8. If we look at the table on the right, it looks like these y values are getting closer and closer also to 8. So what does that mean? That means that the limit as x approaches negative 2 of x squared plus 4 is equal to 8. As x gets closer to negative 2, y is getting closer to 8. This next one, we can see we're supposed to find the limit as x approaches 6 of x squared minus 36 divided by x minus 6. So we want to approach 6 from the left and from the right. And we can see here we're approaching from the left. Here we're approaching 6 from the right. Looking at the y values in this first table, they're getting closer and closer and closer to 12. Looking at the y values in the second table, getting closer and closer and closer to 12. So the limit of x squared minus 36 over x minus 6 as x approaches 6 is equal to 12. As x gets closer to 6, y is getting closer to 12. Final example, we're supposed to find the limit of x squared divided by x minus 6 as x approaches 6. Looking at our tables here, once again we're approaching 6 from the left and we're approaching 6 from the right. It's standard procedure at this point. Notice something different though. As we looked at these y values in this first table, they're getting huge negative. If you look at the y values in the other table, they're getting huge positive. They are not approaching the same number. For a limit to exist, it must approach the same a single number, or the same number from both sides, from the left and from the right. So what is the limit of x squared divided by x minus 6 as x approaches 6? Well, we simply say it does not exist. Does not exist. For it to exist, it must approach a single number.